ever since the first whisper of an incoming interstellar visitor reached the astronomy community. Excitement has been steadily building, and with the recent developments surrounding Comet 3 I/Atlas, that excitement has erupted into a global scientific conversation. Following the end of the U.S. government shutdown, NASA has moved quickly to begin releasing some of the highest quality imagery ever captured of the comet, and early reports suggest that the data taken by the HiRISE camera aboard the Mars Reconnaissance Orbiter could surpass all previous views, including those captured by the Hubble Space Telescope on July 21, 2025. HiRISE, known for its extraordinary ability to photograph surface details on Mars down to remarkable resolutions, has now turned its gaze outward, offering a chance to see 3 I/Atlas with a clarity that scientists had only dreamed of until now. These new observations are expected to play a crucial role in deepening our understanding of the comet's structure, brightness, fragmentation behavior, and the mysterious nature of its interstellar materials. The comet itself has become an object of fascination precisely because of how unusual and dynamic it is. In just a short period, 3 I/Atlas has brightened dramatically, surprising astronomers with a level of activity not typically seen in most comets passing through the inner solar system. Measuring roughly 7 miles 11 kilometers across, it is not only large by comet standards, but ancient, likely more than 7 billion years old, older than the Sun itself by several billion years. Its materials, exposed to relentless cosmic rays for eons, have undergone chemical and structural transformations that scientists are only beginning to unravel. When we consider that this comet has spent nearly all of its existence wandering the interstellar void, far from the warming influence of any star, the idea that it has survived long enough to pass through our solar system feels almost miraculous. Now, traveling at an astonishing 130,000 miles per hour, 210,000 kilometers per hour, it is shedding its irradiated coma in spectacular fashion, leaving behind a luminous veil that stretches across the darkness of space. While we wait for NASA's forthcoming data release, amateur and professional astronomers alike have been capturing astonishing images of 3 I/Atlas, adding to a growing gallery of visuals that showcase the comet's dramatic appearance. One particularly breathtaking shot was recently taken by renowned astrophotographer Satoru Murata, who managed to capture intricate structures within the comet's tail just before dawn. The delicate strands and subtle curves within the tail suggest layers of dust, gas, and charged particles reacting to solar radiation and magnetic fields in ways that differ slightly from ordinary comets native to the solar system. To the right of Murata's striking image, the galaxy NGC 4691 can also be seen, providing a stunning cosmic backdrop that highlights just how vast and interconnected our universe truly is. The viral spread of this image has prompted renewed public interest, drawing in science fans, space enthusiasts, and curious onlookers who may not have followed astronomy before, but now find themselves captivated by this visitor from beyond the sun's dominion. The question that many newcomers inevitably ask is, what exactly is 3 I/Atlas, and why do so many people care? The answer is rooted in the comet's rarity and scientific value. 3 I/Atlas is only the third confirmed interstellar object ever detected in our solar system, following the famous Oumuamua, 1 I/2017 U1, and Comet 2 I/Borisov. Unlike the countless comets native to the solar system that originate from regions such as the Kuiper Belt or the Oort cloud, this object comes from entirely outside our cosmic neighborhood. It originated somewhere in the Milky Way, but where exactly is still a matter of active investigation. Based on its trajectory and chemical behavior, scientists have debated whether it emerged from the Milky Way's thin disk or thick disk, two regions with distinct populations of stars and differing metallicity levels. The uncertainty adds to the intrigue, because if the comet originated from the thicker, older disk, that would explain its extreme age, more than 7 billion years, and help astronomers understand what materials existed in the galaxy long before our sun was born. Tracing the comet's path has been especially difficult because its composition has been altered by billions of years of exposure to cosmic rays. These high-energy particles, drifting across interstellar space, bombard objects relentlessly, reshaping molecules, eroding surfaces, and potentially creating exotic chemical bonds that we do not commonly observe on objects formed within the protective cradle of our solar system. This means that by studying 3I/Atlas, astronomers may be able to access a chemical record preserved from an era predating the formation of planets, moons, and even the sun itself. Every spectrum, tail measurement, brightness fluctuation, and dust release event could offer clues about the environment in which the comet was born, the conditions it experienced over billions of years, and the larger story of how material moves between stars and galactic regions. Observations show that the comet passed its perihelion, the closest point to the sun, approximately 2 weeks ago, and is now making its way toward its closest approach to Earth, which is expected on December 19th. While it poses no threat to Earth, its proximity provides a rare opportunity to study an interstellar object at a relatively close distance. These weeks leading up to its Earth flyby represent the most valuable observation window, as the comet remains bright, active, and highly responsive to solar radiation. Its unusual behavior, from the composition of its coma to the surprising structure of its tail, has already sparked a wave of scientific papers and preliminary analyses. Adding even more intrigue is the burst of speculation claiming that 3I/Atlas could be an alien probe. Such theories, while imaginative, are almost certainly incorrect. The radio signals detected coming from the comet are entirely consistent with natural cometary emissions, typically caused by interactions between the sun's radiation and the molecules in the comet's coma. These signals, microwave radiation, simple emissions from ionized gas, and thermal signatures, are well understood and have been observed countless times in other comets. Yet the sheer uniqueness of interstellar objects, combined with the public's fascination with extraterrestrial life, often fuels speculation long before the scientific data has been thoroughly analyzed. Still, the scientific community remains extremely enthusiastic about studying 3I/Atlas, not because it might be artificial, but because objects like these give us a chance to examine the building blocks of other star systems. Every star, every planetary system, and every cosmic region has its own chemical fingerprint, shaped by its age, the materials available during formation, and the events that have influenced it since. By studying interstellar comets, we effectively gain samples, however brief and distant, from regions of the galaxy we cannot physically travel to. This makes 3I/Atlas not only fascinating, but profoundly important scientifically. Its dust grains, volatile compounds, and structural layers may hold information about the early galaxy, the formation of distant stars, and the long-term evolution of materials drifting between solar systems. As researchers around the world prepare to analyze the upcoming HiRISE data, combined with ground-based and space-based observations, there's growing anticipation that 3I/Atlas could answer long-standing questions about interstellar chemistry and cometary physics. Scientists hope to determine how objects survive the harshness of interstellar travel, how their surfaces evolve over immense timescales, and whether the galaxy is more chemically diverse than previously believed. Every new image, spectrum, and data set brings us one step closer to understanding not only the comet itself, but the vast and complex environment beyond our solar system. In many ways, 3I/Atlas reminds us that the universe is full of wanderers, ancient travelers that cross star systems, carrying with them the stories of worlds we may never visit, yet whose histories become part of our own cosmic narrative the moment they drift into our skies.